Hey, what's up everyone? I'm Pux Patel, and this is our final demo for BlenderCollab. It's basically Git, but for Blender. I'll get us started.
Hey, I'm Marsh. I work mostly on the back end, stuff like the API, the database, and a lot of the version control logic that ties everything together.
Hey everyone, I'm Alex Mesa. I helped set up the fast API backend early on, and I owned most of the testing, unit test, behavior test, and role-based auth stuff.
Hi, I'm Robbie Van. I built the Blender add-on, the plugin that runs inside Blender, and I worked on the merge conflict resolution flow on the add-on side.
Hi, my name is Vraj Patel. I worked on the database layer, the S3 integration, and the general project collaboration backend.
And I do the front end, the website, sign up flow, project pages, all that. Together, we're the capstone bots. For the next 12 minutes or so, we are going to show you what problem we set out to solve, what we built, and an actual end-to-end demo with two artists working on the same scene.
Okay, so picture any team working on the same Blender scene. One person's modeling the monkey, another's lighting, someone else is texturing the terrain. The way most teams handle this today is honestly kind of rough. They zip up the .blend file, drop it in Google Drive or Dropbox, and whoever opens it last wins.
And that sounds like a nightmare. Dot blend files are huge. We're talking about hundreds of megabytes per scene, sometimes gigabytes. You can't just throw them into regular Git. Git's not designed for that. People have tried Git LFS, but it still treats it as a whole file, as one whole blob. So you're moving the entire scene around. So if you did change one object, users can't really see that.
And there's no merging. Like if two artists touch the file at the same time, one of them is just out of luck. The changes get overwritten or they have to manually redo it. That's where you get those scene underscore final underscore actually final underscore v2 dot blend file names. That's the team trying to do version control with the file names.
Okay. So we asked ourselves, what if we treated each Blender object, each mesh, each light, each camera as its own version thing? Then two artists working on different objects don't conflict at all. And when they do touch the same object, we can actually show them what changed and let them pick.
The goal from day one was object level version control. Per object diffs, per object history, per object locking if you really need it. That's the core idea.
So instead of versioning the whole file, we version individual objects inside Blender. Meshes, lights, cameras are all separate. That means multiple people can work at once without collisions. Let's show that in action.
I'll start by creating an account. Here I can sign up, name myself, put my email. Put a password with all handled through jot tokens. Here it'll get sent to your email to get verified. Here you'll verify, and then you can log in. Here I can create a new project. Let's name it Monkey Scene. A small scene with a monkey. Create the project. Inside this project, it'll show commits, branches. I can create new branches as well. Let's name this test. And I can delete those branches. Here, I can invite Alex Mesa to my project. Alex, did you get that invite?
Yes, I did, Pucks. So on my end, if we go from the beginning, once you log in, this is what you're going to see. And right here on these tabs, you're going to see a notification on the invitations. So in here, this is the project that Pucks had invited me to. I'm going to accept. Now when I go back to the projects, I'll see the project here. When I open it, you can see everything that's on here. And if he would have had the branch on there, I would have seen the branch as well.
On my side, I can manage who he is on my own side. I can change if he's an editor, if he's a viewer, or if he's even the owner. Right now, we'll keep him as an editor.
Okay, so now on my end on Blender, I'm going to open up the BVCS and I'm going to log in. Now, once it's loaded, I'm going to open the project that I got invited to. Make sure that one's it. I'm gonna open it. So now what I'm going to do is I'm going to create the first commit. So the first thing you do is you need to stage all, commit changes. Let's just name this block. And then we're going to push to remote. And then down here it says push successful, 3 uploaded. And it also says it here. Now when we look on the website, we refresh the page, we see that the objects are here.
Wow, Alex, I can already see it on my side. Once I refresh, it says camera, cube, and light, all separated into different objects with different blob hashes, all available to download straight from the website. I can see his old commit that he had, and I can see that he's still a part of the project. From here, I can see that, let's say I log in on my side. I open the project. And then let's say I make a change. I want to add a monkey. I want to add my monkey in here, like right above the block. And then maybe I want to delete this cube. Or actually, let's just move this cube. I think we make it behind the monkey head. And then we can refresh our status. We can see that we added Suzanne and we modified the cube. We stage everything. And then we commit changes. Let's name it add monkey, move cube, something descriptive. Click OK. Then we'll push to remote. Oh, I have no commit base. We can pull from remote. And we get a merge conflict. Here on our merge conflict, we can preview what the remote shows. It'll open up a new window, and you can see that it's just a cube compared to me having the cube moved and having the monkey there. I kind of like what I have, so I want to keep my local. Let's apply the resolution. It will say that we that there's a merge committed, and if I refresh the page here, it'll show that I committed a merge. And you can see that Suzanne got added and the cube is there as well. So after that resolution, I'll send it over to Alex to see what it looks like from his side.
So I had already refreshed the page, but as you can see on the website, you can see the merge had already been resolved by Pucks. So now we're going to try to see that in Blender. So all we're going to do is we're going to pull from the latest from remote. And as you can see, it's the objects that he had just added and the changes that he made.
Now, to wrap everything together, I'm going to talk more about how we built the project. Starting off with the backend, we used Fast API and we have full test coverage to make sure everything works properly. For the front end, we used Next.js as a very intuitive and user-friendly system. For the backend, we also connected it with S3 storage at AWS S3. That allowed us to have object storage and keep data such as mesh data, as well as objects storage such as GLB, as you saw earlier on the web app side. We also have the add-on, the extension that was written in Python using Bot03. That allowed us to create a proper extension that people can download and add onto their local system. Now, I'm going to hand it off to Raj to do a conclusion.
Yep, so instead of sending files back and forth, we collaborate directly inside of Blender with real version control systems underneath. And with included security and testing built specifically for 3D workflows. The use cases for this are nearly endless. You could be working for a visual studio and with a team of people working on a 3D model, and you can easily communicate between each team. All a company would have to do is simply buy their own S3 bucket. Another use case could be simply a professor who's teaching a simple Blender class. They can easily track what each student has done, individually see what they've changed, and see which student is putting in a said amount of work. Very similar to how GitHub currently operates. That is BlenderCollab.